Have you ever sat and stared up at the stars and wondered, where did we come from? Let's take a journey like no other, not to a place, but to a time. Join us as we delve deep into the human past and explore our shared human origins. Welcome to the world of paleoanthropology. Hello, everybody. This is Seth with the World of Paleoanthropology, and today we have another special guest from the Rising Star team, Dr. Juliet Brophy. How are you this afternoon?
Doing great. How about yourself?
I'm good. It's great to have you on the show. So, as I mentioned briefly, of course, you're involved in Rising Star. Why don't you tell us a little bit about who you are, kind of where you got there, how you got there, and a little bit about yourself.
Okay. My name is Juliet Brophy, and I am a paleoanthropologist at Louisiana State University. I'm an associate professor there, and I started working in South Africa during my master's and just fell in love with it. I actually fell in love with a picture of Mrs. Ples during undergrad, and I really wanted to go to South Africa to work on her, which is a little ironic because she doesn't have any teeth, but I always keep her nearby when I need to. But yeah, so I really wanted to go to South Africa. I did my master's down there, and then I started working with Gerald DeRuyter at Texas A&M with my PhD. And I did a lot with morphometrics and trying to identify animals in the family Bovidae using the morphometric approach. In 2010, I started using a similar approach, using that same morphometric approach on hominid teeth when we were investigating the species designation, or actually the genus designation of Australopithecus sediba at the time. And so I developed this huge database of hominid teeth in Southern Africa. So when the call came out for early career scientists to work on the teeth on Homo naledi, that they wanted people to work on those, I had this massive database of, again, this morphometrics analysis that I had done on all the teeth from Southern Africa. And at the time, we had no idea what those teeth were, what genus, what species. We had no date for them whatsoever. So that's when how I got on the teeth, I think.
That's amazing. So you were in the tooth booth.
Yes.
Is that what they called it? Yes.
Mm-hmm.
Okay. So specializing in teeth, what can you tell us since we're talking, well, let's preface a little bit what we'll be talking about later on. And that is, of course, the discovery of Leti, which is the Homo naledi adolescent that was discovered, I believe, in 2017. And then announced late last year, very towards the end of the year.
Yes.
And I know you
very much
were
a timeline.
Yes, it was. I was very excited when that announcement came out. I know Professor Berger kind of gave a sneak peek like a few days before, and everyone got real hyped up for it. So knowing that you worked on that, what can you tell us about Homo naledi's teeth that make them different than, say, our own?
From our own?
Yeah.
So a couple of things. They are, the shape is a little bit different, particularly the mandibular P3s are pretty unique in their overall, in their occlusal shape or their crown shape morphology. So the chewing surface of them, so that makes them somewhat unique. We find the canines have this cuspule or cusplet, depending on who you're talking to, the name of that. So they're going to have those, something that we don't have. They have a molar size gradient that's different than ours. So the derived or modern molar size gradient is that the teeth are going to get smaller as you go back in the mouth. So the third molars are typically the smallest, the first are typically the biggest, sometimes one or two are the same size. But for Homo naledi, they have the primitive size gradient. So they're going to get bigger as they go towards back mouth. So the third molars are the biggest. So that's another unique component to them. We find, particularly with some of the deciduous teeth, they're a little bit longer, more buccolingually narrow than we see with modern human teeth, which can be a little more square or trapezoidal in terms of the molars. What else? Those are some of the big characteristics that make them different. But I guess, and another thing that I think makes Homo naledi teeth different than modern humans is how similar they are. So we say they have very low intraspecific variation. So across naledi, Leti, and now with the site 110 with Leti, they're very consistent in their shape and size, morphology, their characteristics. And so their lack of variation makes them unique. Especially when we compare that to species like Australopithecus africanus that has a large amount of variation. Now there's a lot more of them and they're across more sites. So we think that's probably why, and with that there's a longer time frame that's involved. But we don't necessarily have that with Homo naledi. But again, they're super consistent across their shape and size and the morphology. So that to me is a very unique, very interesting part of that too.
Most definitely. I'd say that's, as far as I know, much less common than, as you said, we see in other species. So what got you interested in teeth so much specifically?
I think part of the reason is that my dad was a dentist. So I got interested in teeth really early on. He fashioned himself an amateur archaeologist. And just knowing that about teeth, he got me onto a field school right before I went to undergrad at Michigan, and he went as well. And so we just got into archaeology, but then again, talking a lot about teeth and how much they're preserved. And then when I got to Michigan, again, we kind of followed up with that interest, right? And then just how well preserved they are and how much we can learn from teeth. I think that they're absolutely fascinating. And so again, with my dissertation work, I was using morphometrics to look at animals in the family Bovidae in particular, and use those in order to reconstruct past environments. And so we really looked at the occlusal surface of bovid teeth. And to me, it was fascinating that we were testing, and so many people use that occlusal surface, the shape and the size and the characteristics, to identify them. I didn't necessarily think, there seemed to be a lot of overlap between them. So I didn't necessarily think we were going to be able to differentiate between the different species just based on the occlusal surface. But it turned out we can differentiate them through sizes, as well as, sizes, but the different tribes, as well as the different genus and species. And so I think that, again, just my fascination continued, then started getting into the hominid stuff in 2010 and really delving in a whole new world. Obviously, it's a little bit different because when we look at animals of the family Bovidae, we can compare the bovids from today to some of their fossil counterparts, right? So some of them they're the same species that are around for the last 3-4 million years. Some of them, obviously, we have some extinct species as well, but we can look at those shapes and sizes and see how they're related to each other. So we can't necessarily do that with hominins, obviously, because they are not. We can't just compare the shapes to modern ones to the past, but we could still look at the shape, how that shape has changed, to look at evolutionary relationships and who's related to each other and how related they might be in terms of the genera and the species. So they're just fascinating how much we can learn about them. Just the shape, the size, the pits, the scratches, the isotopes, what they're actually made of, everything about them, I think are fascinating.
It definitely is. And I think a lot of people either underestimate or don't know just how much you can learn from teeth. I mean, we can learn the diets of ancient individuals, the environments they lived in, all of these sorts of things based on their teeth. And having experts such as yourself who understand that, I think, is a key role in understanding the niche that, say, Homo naledi would have filled. And I think that's important to paleoanthropology because of the multidisciplinary approach that's required of not just here's some bones, but here's where they lived and what they did. So now getting more into Homo naledi, why don't you tell us about this most recent announcement from Rising Star?
So the most recent announcement and the most recent paper is that we have a juvenile that was found all by itself, a juvenile skull that is found all by itself in this very hard to reach cubby. So we've got the naledi chamber that was found, that we announced in 2015, that's found of 15 individuals, and we have loads of bones and repeated elements and 190 teeth, at least 190 teeth. We have more than that now, but we've got that site. And then with Leti, we announced in 2017, we have 3 individuals. They're somewhat separated, so maybe not the same space, but we have 3 individuals Well, with Leti, we have, again, only a single skull, and it's a juvenile, so they're all associated with each other, and it's 6 teeth and 28 cranial fragments. And so we can put together a rough approximation, because we know they are associated with each other, of what that individual would have looked like. We've got 2 deciduous teeth or baby teeth, and then we've got 4 unworn adult teeth. So that gives us a rough idea about the age, and we think they're around somewhere between 4 and 6 years of age. We also have the cranial fragments are associated, are similar. They align with that time frame, with that age. We also, the biggest piece that we have is part of the frontal, so we can piece that together is here, and then we've got some from the back of the skull. So we do have to make some estimations of the rest of it, but it looks pretty similar. The size is similar to what we find with the Tom child, additionally enough. So the most fascinating part, I guess the 3 parts that are the most fascinating on this is that we have deciduous and adult teeth and the cranial teeth all found in direct association with each other. So again, we can look at a single individual. With naledi, we can estimate some of the teeth that went together, but we can't directly associate them with the bones because they're somewhat scattered around. So we don't have a good idea of that. We know this is 100% associated with each other. So that's the first aspect. The second one is that it's found in this very hard to reach cubbyhole. There are a number of different, we have a couple of new sites. I think Lee touched on some of them when he talked that so like Leti is 105, this new site is 110. So there's a number of different, I'm sorry, that's not 105, that's 102. But he's looking at 105. There are other sites that have come up. And so this is 110. So you know there's 6, 7, 8, 9 that are in there. But we know that this is a single individual that are all close to each other, but again, in a very hard to reach cubbyhole. So someone had to take a lot of special time to travel back to this very hard to reach area to deposit the skull. So that I think is very fascinating. And again, the difference and how consistent it is across all the species, all the specimens we find in 110 are very similar study, as well as very similar to naledi. To me is super fascinating, suggestive of a related group, right? So this one large population that was together.
And you know, as I mentioned, I think before the show started, anything Homo naledi related is just my favorite. They are my favorite hominin. I have Neo behind me, but here's just the original. Neo's behind me, and I actually have Leti on the way. A nice print of that. I wish it was here.
Ordered them, or you're printing them?
Dr. Jeremy De Silva has been kind enough to provide me with a skew of fossil prints, so that's been very nice. But so when we're talking about Leti, and I was actually talking about this in one of our groups today, and as you mentioned, it took someone a lot of dedicated time, presumably thought and effort, to put this cranium there. Now I know no one's going to say the B word because because no one wants, you know, all that backlash, but we're getting close, right, to being able to say that.
I mean, yeah, we continue to reject every other hypothesis, right? I mean, especially in this very hard to reach area. There's no, I mean, again, no taphonomic marks. It could not have been washed in, you know, there's no carnivore marks on it. There's no other bones found with it. And I think, I mean, all signs are leading that direction to that burial. So, Daryl the writer actually gives a great TED talk. We've seen that one on the deposition or burials of Homo naledi. So I think that helps sum it up. I mean, it's not that random of an activity.
Definitely. And I think the implications of that are just fascinating. And of course, there's going to be people who don't necessarily agree with that. I, for one, find it, as you said, quite hard to refute at this point. Now, when we're talking about Leti, you've mentioned it's just a skull. There's no other postcranial remains. There's nothing. So
let's put that into context, though, because it is a very hard to reach area, and the cavers only did surface collection at the time. So here are the options of that. So it's either that someone placed a skull into this hard to reach cubbyhole, which is odd, right? It would be a little odd, especially if it was your offspring, right? The other option is that, again, we're not getting a lot of degradation of the cave. The sediment, right, is just coming from the caves, the outside of the cave, and not any washing, any other sediment that's occurring, or anybody tracking anything in, that the animals or anything. So we don't have a whole lot of sediment. So the only other option is that they took the body of a 4 to 6 year old and dug a hole and just filled it up to here, just above the skull. Equally weird, right? So I would like to do some more excavations there. I'm not sure how feasible that is, just because it is such a hard to reach area and it's not very safe. But I'm not sure our implications or interpretation of it is going to change much after if we were to learn that there wasn't anything underneath it, or that there was. It's a kind of an odd behavior to do that.
Right. Now, speaking of excavations, we've all heard the story of the original team going in, and the whole trek that you have to go through over Dragon's Back and everything. How much harder is it to get into this new chamber? What was the name of this chamber? The Chaos Chamber? No?
Pandemonium.
Pandemonium.
Yeah, so there were a set of cave names. We were not allowed, we were under strict orders, they were not publishable. Just because they were the cave name, the names the cavers gave them, because they were so difficult to get into. But yes, Chaos was one of them. Pandemonium, there was Hades was one of them, was another cubby hole that was hard to get into. But yeah, so we don't use those, but those tell you how difficult they are to get into. That's definitely more of a Marina question. I just gave a guest lecture in her class in Canada, and we talked a little bit about that. But yeah, they were very difficult and a lot of safety. Hence why there was just surface finds. I mean, Becca talks about, she's the one that actually excavated that cave, and I don't know if you saw the press release, but she said she was upside down, reaching into it. I thought, wow, so grateful, but wow. That's a lot of dedication.
Yeah, that's for sure. I can't think of a similar paleontological endeavor that matches what's been done at this site. Yeah. So what do you think we're going to learn next from what we have? Of course, I'm sure there are hundreds of avenues, if not thousands, that could be gone down. But what do you think is next that we'll learn from Leti?
The next big find? It'd be nice to find more of an adult individual found altogether. And to be honest, it'd be excellent if we could find Homo naledi somewhere else. How do we have such a large population at one site in this cave system? I mean, it's not one locality. We have 10, 11 localities in one cave system. In the cradle of humankind, where we have loads of other fossil sites. And trust me, we have looked at other fossils that are ambiguous, archaic Homo sapiens, or Homo spa, which is a lot of what we have in Southern Africa. Homo is notoriously undefined in South Africa before we got Homo naledi. So we've looked at some of these other fossils. Could they be Homo naledi? And so far, we've rejected a lot of these other specimens. So, but it would be nice to find them at another site. The other thing that would also be really interesting is to look at, to see what would cause the differences that we see with this species. So what natural selection changes. So what would the environment look like that would cause selection for the traits that we find in Homo naledi? So, or even sediba, even Australopithecus sediba, because we don't have a really good idea of what that environment looked like over time. So, but we have these two relatively new species, only at one site, both of them. That to me is kind of fascinating. What's going on down in Southern Africa? And again, so it'd be really great to find that another site. Something that I'm specifically working on is more of the deciduous angle, or the juvenile angle. So I'm putting together part of it for the upcoming AABAs and meetings, to look at the juveniles. So, I mean, for the first time, we have, again, an individual, these cranial pieces in direct association with some deciduous teeth, and then we have some other individuals where we have more than one specimen per individual. at both at Leti and then one at Leti that we can try to compare some of these early juveniles at. So what can we learn from that growth and development patterns? Are they similar? Are they different? We've got so 5 early juveniles, we've got a late juvenile, and then we have some infants, some even younger ones. A lot of these, I'm working with Deb Bolter. She helped define some of these categories. So I think, again, we can learn this because it's such a unique opportunity. There's so few other sites that have more than one even deciduous tooth, but to have more than one individuals composed of multiple specimens. And so to me, I think this is a great opportunity to learn a lot more about the kids. A lot of times you'll find papers that will talk about, that will describe some of the teeth and say, okay, we have these 2 deciduous teeth and this is what they look like, but they won't specifically say the teeth of, for example, Homo erectus look like X, because they only have 2, or 2 at this site and then maybe 2 in Africa and 2 somewhere else. And so it's very hard to talk about of the species characteristics versus, again, we have this opportunity to Homo naledi because we have multiple teeth across a couple different localities, even though they're so close to each other, located so close to each other.
Amazing. So speaking of comparing, we talked about how close Leti resembles the Tong child. How do the teeth compare?
There are some similarities, but the teeth are a little bit more derived than what we see with the Tong child. So it doesn't have a lot of overlap with Australopithecus africanus. In fact, it has some interesting overlaps with Australopithecus robustus, interestingly enough. And so there's a little bit of overlap with that, but much less with Australopithecus africanus. So it's not necessarily unexpected in that regard. To me, that's really interesting to find some of those similarities of a species that is considered an evolutionary side branch.
Right, definitely. So how do you have any explanations that you can think of why we only have a single species in a locality that's underground? How does that, has the team come up with reasons on how that's even possible?
Sure. I mean, how that's possible? Do you mean in like that why we don't have other hominins added, or why we don't have other species?
Well, why Homo naledi is not been found literally anywhere else?
Oh.
Like nothing else of the.
I mean,
yeah.
Maybe we haven't dug enough or in the right spot. I mean, obviously we're looking, we're out looking at other cave sites, but I mean, it's pretty lucky, fortuitous how we found this. I mean, recreational cavers found it first and then told other cavers that eventually led to Wits University and Lee Berger, obviously. But this is, so maybe we just didn't run into that same situation. Or again, there's some sites that have been dug that maybe they just didn't get deep enough at some of those sites. We're in the younger layers, the overburden, if you will. I'm kidding. Until we get to the older material, 300,000 time frame. That's another hypothesis. Maybe they liked how difficult it was to get into this cave versus some of the other cave sites. Sturkmatane, for example, is not particularly difficult to get into, at least some of the passages. There's other ones that are a little bit harder. And so maybe that was a preference in that regard. I wouldn't think, honestly, I think they're out there. We just haven't found them.
Okay, well, that's definitely a hopeful, and I hope definitely we do find them, because I think, as you said, it'll definitely reveal much more about their behavior and why obviously they were putting them in caves once they were. Now, one thing I've never asked anyone, so is there any evidence to show that any of the remains were there prior to being dead? Like, did any naledi die in the cave, possibly?
We don't have any evidence of that, no. So there is a site, a part of Makapanskat, that is only about 10,000 years old. They had some mummified individuals. And so what they had done is they crawled into this cave for whatever reason, and they had jammed themselves up into this part of the cave and literally died there. But the position of the bodies, they're all associated with each other, the whole body part are there, so that gives us taphonomically an insight into how they actually died. So we don't have
Okay.
evidence of that at hominoid. But I
Okay.
mean, again, if it exists, could it have happened? I don't know that we don't have any supporting evidence of that. But if they did, they have since fallen apart or down certain areas wherever they would have crawled into. There isn't a lot of support for that.
Okay. Okay. That makes sense. Now, going back a little more towards yourself and your career and what you do as a professor, what brought you into education and working at a university, and what led you down that road besides just your interest in the field?
What particularly into academia? I think one of the reasons is because I fell in love with anthropology in a classroom. And so I had this interest when I went on that field school, and that first
Mhm.
field school was in Belize. So I spent, a couple summers out working out there. Again, my dad and sister. It's kind of like a fun thing. We got some college credit for it, but it was just some interest, and then when I got to university, I thought I took some of the classes because I thought they were interesting. And I found I had to do that homework last because I wouldn't get to the other homework. Then sophomore year, I believe it's not a sophomore, I think it was sophomore year. I took a class with John Matani, and then I took a class with Milford Walpoff, and
Oh,
I was hooked. So I was just totally enamored with this field. And again, so I continued to take all these classes because I absolutely loved it. And again, had to do everything else, my other homework first because of that. So I wanted to, that's one of the reasons I wanted to teach. Obviously the research thing is a no-brainer. I'm curious about where we came from, the fossils. I fell in love with South Africa super early on for reasons I really can't fully explain, other than I really wanted to study Mrs. Ples, find Mrs. Ples. I mean, not find her, but see her. I got so excited the first day I saw her. I was working at CPA on a field school with Steve Churchill, and I was like, that was amazing. And going in the broom room at the museum, I was just euphoric. So I really wanted to impart some of these feelings that I had, that passion that Milford showed in the classroom to my students, and show them how awesome anthropology is. So I consistently teach intro to anthropology, intro to bioanth, because I know that there are some kids in there that are only there because it fulfills a requirement. And that's my one chance to show them how awesome anthropology is in general, biological anthropology is. And so that they can say, oh, I took a class once and I learned about X, and I heard about, these fossils, and I thought it was awesome. Right. And then there's other kids that are going to get so enamored with it, similar to how I got into it, that are going to get hooked, and they're going to want to take more classes and continue more. So I always do the undergrad, the intro, and then I do either a 4,000 and then either 7,000 for grad students. But I really like that mix, again, so I can impart this enthusiasm, I guess, for lack of a better word, because I absolutely love what I do, and I think it's exciting. So then I also like the research wise goes hand in hand, because I can tell the stories. When I saw this fossil, when we dug this up, we have one short, unfortunately, very short archaeology section. In a bioanth class, we don't spend too much time on archaeology, but just talking about the context. And so I can show all these pictures from the field schools I've been to, from the, sites Daryl and I ran within in the Free State. We ran a site on there for 3 years, worked at Gladysville a little bit, Cooper's, Plover's Lake for a number. I did my master's at Plover's Lake, all these sites, with the cradle, and then as well as in the Free State. And so I could show those pictures. It's, I was down there, I got dirty, and I was, showing them these pictures. And I think that experience changes the teaching experience, changing how you're going to learn, the learning experience.
I have to 100% agree with you, as one of those students that took a bioanth, 101 class, and was just, I was a deaf studies major. I wanted to be a sign language interpreter, and it was just a GE class I was taking. And I have never looked back even the slightest bit. And I have to thank that first professor, because she showed similar enthusiasm to what you're talking about. And just, it's people like her and like you who I think, I actually didn't realize this until you mentioned it, but I always wonder because I see these professors teaching bioants 101 or whatever, and I'm like, why aren't they teaching higher level classes? They know more, they, etc. But understanding that you're doing it to inspire people who might not, or at that teetering threshold, makes perfect sense. And I have to, take my hat off to you for that, because that's how you really get the people into the field, and that's what pushes the science forward. So I think that's great that you do that, and I really appreciate the fact that you do, and others like you. So one question I always like to ask my guests is, and it's usually the hardest thing that I ask, and I purposely didn't put it in the outline because I didn't want you to know.
Okay.
Who is your favorite hominin? Like, what species?
I think it's tough, but I usually go with, man, it's really tough. It's tough because I originally got into the field because I fell in love with Mrs. Ples, Australopithecus africanus, but my dissertation work was all looking at Australopithecus robustus, and if there's one species that keeps me up at night, that is it, because my dissertation was trying to test. I mean, a lot of people say that it was found associated with one type of environment, open and lightly wooded grasslands situated in habitat mosaic, whatever that means, right? And so that's what I was testing. Was it found at the same environment across all these sites? And I found that it wasn't. So it seems more of environmental heterogeneity. There's more environmental heterogeneity than we thought. So it's not a habitat specialist. Well, then why did it go extinct? Then what happened? Right? So we talk about aridity changes and things like that. So part of me is like, maybe it's that one because I think so much about it. But then Homo naledi, I mean, I also think a lot about that one, and how much that, how interesting is that there's so much homogeneity across the morphology of those individuals, and learning a lot more about what we can learn about the deciduous, the juveniles. And I guess I would have to go with the one that's the background on my phone, and I guess it's Mrs. Ples.
Tried and true.
I mean, but that is a tough one, and I think it's changed over time. But every time I go to South Africa, I make a trip, and I mean, as many days you spend in the field, and maybe you're not the cleanest of individuals, right? Because you're working hard, and excavating and whatnot. When you go see Mrs. Ples, you're like, all right, here we go. Like, it's here.
That explains it perfectly, and I think that's a great way to put it. Now, so looking back a little more at Homo naledi, for those of us who may not know, for a little review, I guess we should have started with, can you tell us who Homo naledi, or what Homo naledi is, where they fit in things, if you can? I know it's a broad question.
No, we don't know where it fits. We originally started excavating, when I got down there, they had excavated a lot. They had excavated in the fall, they excavated in the spring for a couple of weeks, but then we got down there to start analyzing everything. It was just such a mix of traits that we really didn't even know what genus it should be in. And that was one of the conversations. So again, the tooth booth, hip heaven, handland, I mean, there were all these different places to the lab, and we would get together at night at the local water hole and chit chat about what we found, and we'd have our computers out. We'd work with the fossils for as long as they would let us, and then we get our computers out and PDFs and discussions about all these different species. And you've got the hip people are saying, no, it's definitely an Australopithecus. It's also for sure. And again, the teeth, like, no, it's Homo, maybe, like a little Homo erectus. It's, which a lot of other people have said so that's one aspect that it looked very Homo-like, and the hand was very transitional. And so we developed, this is ultimately why we came to the conclusion that it was a new species, but it had enough characteristics to put it into the genus Homo. How it fits into the timeline though, we have no idea. When I first started giving talks on this, when we first announced it in 2015, I said that it was, I mean, morphologically, it looks to be about 2 million years based on the pelvis. And to me, that's very compelling. If you want to put these specimens into Homo erectus, that's fine. We just have to completely change the definition of Homo erectus as we know it. And you'd have to have a major reversal in the pelvis, right? And then a locomotion, which seems bizarre and not parsimonious at all. So again, which leads us to the new species. So again, we thought it was maybe early Homo, very early Homo, especially maybe with some of the characteristics it might share with sediba, but okay, now we know it's 300,000 years old. And again, definitely in the genus Homo. I don't know where it fits in the evolutionary time frame. We're still trying to figure that out. That's a really difficult question.
I think that was a perfect answer. I was hoping for something along those lines. Now, of course, the dating, if I'm correct, is somewhere like 230 to 330. So that puts them, of course, in the range of modern Homo sapiens in South Africa, especially with the later dates for Homo 1 pushed back now.
Yeah, and Dr. Hood, the Morocco.
Of course. And what do you think we will find anything that would show any sort of interaction? Or do you think possibly
that's a
in the genes
possibility.
we might? You think so?
Yeah. They look different. How much different? It seems to be there's a lot of new research talking about how much more integration, how much more interbreeding than we had. And that maybe the model's gonna be a lot more baboon-like, where you have different genera that even interbred, you know, maybe even perhaps had fertile offspring. They didn't do it super often. So part of that would fall into the line of, I would really like to find Homo naledi somewhere else. Super fascinating. We found it in East Africa, but I'm not holding my breath. We can't even find it at a second location in South Africa. So, and we know there's a large population there. But that I think we need a lot more data for that. But I don't think it's outside the realm of possibility, because again, it seems like a lot more of the models and other species, if we look at those other non-human primates, that I think that is a distinct possibility.
Now, for the fossils that are in Rising Star, do they all are they all around the same age in the whole system, or is it some variation in there?
We have not. We've only dated the one dating paper that we came out with, and so we have no reason to believe that they would be markedly different. But I think at some point we should get a second data point. I don't know if that's on the horizon, but that's probably a good idea. But again, we have no indication to think they are different, and they all look similar to each other, and it seems more of the same. But we haven't done.
So is there any way to, and I have no idea what I'm talking about at this point, is there any way to, based on how many are deposited there, to somehow calculate a population size for the local area?
I mean, we can make estimations. Sure. I don't know how skewed it would be, right? I mean, so we have sites, we don't have great provenience data for Australopithecus africanus, but based on the morphology and the first and last dates that we see them at a couple of sites, we see some morphological change, right? So it'd be different estimations, you know, maybe even bigger estimations for that site versus we've got a population, maybe not all that big, that specifically uses this cave as to deposit their dead. And so I think it'd be a little bit harder. We also know there's a lot more fossils in naledi that we have not excavated. And one of the questions is, what else are we going to learn? We have multiple repeated elements, you know, of the dentition of the body. I mean, what else do we need to learn from it? Not that we won't ever excavate there again, but you know, maybe we continue to maybe explore other parts of the cave or other nearby sites to continue to find, again, a second data set, a second location for Homo naledi.
Okay.
That
Okay.
answers the question. So I think we could make a rough estimation, but I don't know how reliable it would be. Again,
That makes
just based on
sense.
how different it is from other sites.
Definitely. Now, of course, you know, things are embargoed, and I'm not sure what you can talk about. So please don't don't go anywhere you can't. But has there been any excavation in the system that's not just what's laying on the ground at this point, or has it all just been here? It is.
Has it all just been what?
Like here, it
Surface
has
finds?
there. Yeah, has there been any excavation below the surface so far, or all just been what's been laying on the surface?
Yeah, I mean, they excavated at Dinaledi.
Okay.
Not much of it, but they're, you know, they did the whole surface finds, realized there was some fresh breakages and bones that were sticking out. So then just concentrate on one area and brought that down. But yes, there have been some excavations at other parts as well. It wasn't all, it has not all been surface finds.
Okay.
I think the
Okay.
110 aspect is just for the sheer fact that it was so hard to reach. You know, Becca's not hanging upside down, setting up a 2x2, you know, 2-inch by 2-inch little square.
Yeah, that would definitely be a sight to see.
Right.
So, if you have any hope for this find, whether it's what it communicates to the community at large or what it shows us scientifically, what would it be? What does Leti represent to you?
Oh, that is an interesting question. To me, what does Leti represent to me? I just get, to me personally, I just got so excited that we had all these pieces that are associated with each other. And again, we had all these bones in Dinaledi, and we do have some that we think went together. I mean, we have a whole bone that's broken in half, so we know these went together. But in terms of more of a pieces, bigger pieces, we don't have a lot of that at Dinaledi. A little bit more at Leti with the adult male, but that was the most exciting part of that. But what would I want people to take away from it? Man, it might be the deposition. I mean, as interesting as it is that I can look at, I can have this associated teeth and cranial fragments all in one, and I can use that to talk about growth and development and how does that relate to Dinaledi and Leti individuals. It is really interesting that we have a specimen with this small brain, a species with a small brain that dates to about 300,000 years ago, and they took either a skull or an individual and took it really far to a really remote part of the cave and deposited that as presumably, so because no one else would find it. No carnivore would chew on it, no human, right? I mean, they thought that's placed there, memorialized forever. And that to me is really fascinating.
And just to recap for people who may not know, the only species that we know of who do ritualize deposition or deposition in general is, of course, us. And then we have good evidence that Neanderthals did. And of course, now we have Homo naledi. So why, and I know—
And how do you want to do archaic Homo sapiens? There's some suggestions of those, but still
Right.
as a Homo sapien, I don't know if you're going to split hairs
Yeah,
over the species name.
But,
yeah, that's true.
So why do you think this occurs so rarely and how it does? Because we have Neanderthals and then we have Homo naledi, and they don't seem to me to be very too similar in ecology or anatomy or how they behave, and yet it appears in both.
No, but with the Neanderthals, it seems that there was investment in other individuals.
Right.
The fact that you have, you know, the highly, you know, the old man from La Chapelle, the fact that you have these, the Shenandoah individuals, you know, one without a lower limb, I mean, sorry, a forelimb, not lower limbs, that you have these individuals that would have, Saint Césaire, that would have required, I mean, if that guy would have been out that individual would have been out of hunting, gathering for some time while it healed,
Yeah.
while its skull healed. Someone helped take care of that individual. And so I think that's all it is, that there was, oh man, I hate to use a culture, but that there was a level of care for your other individuals, that you're living in this community and we care about each other. And that's a basic, you know, as basic of an instinct that is. And I care about you enough that I don't want anything else to chew on you. I don't want anything else to get to you. And while occasionally we have baboons going in the back of caves or hyenas, I mean, it's typically areas that they can get back out of. And so going to these really remote extremes to put a skull in there, a hominin skull, would presume that I didn't want, you know, any other carnivore or anything else to get to that skull, right? So I think that's, you know, it's a level of care, and
So
not just a level of I don't want to smell rotting bodies.
right. So using that logic, and I don't want to stretch it too far. We have, of course, some evidence of this type of caring you're talking about in Homo erectus. Do you think there will ever be any evidence there for some sort of burial? Or do you think that's too far back?
No, I think if that's what the science suggests, if we find something that's what the science suggests, then that's what it suggests. I think we have to step out of our preconceived notions that, oh, they have too small of a brain, or they didn't have these ideas. This doesn't insinuate necessarily in some like an afterlife or a future.
Mm-hmm.
It's just that I care enough about you that I don't want to watch a hyena run away with you. You know what I mean? It could be just that basic, just that simple. And so could we see that in an earlier hominid? I wouldn't reject that. If the science suggested that, I wouldn't say, no, that's ridiculous. Again, I'd want to see what the data look like. But if that's what it suggested, similar to what Homo naledi, people rejected it, that idea, but we don't have an alternative, right? We continue to fail to reject these other hypotheses of why it was found in the cave.
Mm-hmm. Well, I think that is just, you know, the fact that we have such unique behaviors going on in these places that we can not observe, but we can see the after effects of, is something that will definitely leave mysteries for decades and decades to come. And I think that is one of the best things about paleoanthropology, is there's always more to learn. And I think I will give you the floor if there's anything you would like to say at the end, but I think otherwise we will wrap this up.
I think that all sounds pretty good. I'm looking forward to everyone staying happy and healthy, so we can get back out and I can get back to South Africa, look at and excavate, and getting back to some normalcy. I miss the fossils so much. So
I can only imagine.
That's what I'm hoping for. So, but you gotta get healthier first. So
definitely. Well,
thank you for adventuring with us into the human past. If you've enjoyed this video, check out our website at www.worldofpaleoanthropology.org and find us on Facebook, Twitter, and Instagram.